Right, so welcome to kind of an intro to computer vision. And what we're going to do today is learn kind of all the steps around building your own object detector. And if you don't know what that is, we'll go more into that briefly or in a little bit. Setup, so we'll be using all online kind of environments for tonight. So you actually don't need to download or install anything, but what you will want to do is you want to have a modern web browser like Chrome, should work across any browser, any modern web browser. And then you'll need a Google account. We're going to use a tool called Google Colab. It's a tool by Google that's kind of an online environment that's really good for data science and deep learning. And then if you want to do the labeling portion tonight, so which I recommend signing up for this, creating your own data set, and then training a model on your own data set in the future. You can sign up here and then use this. Oops, I exited out of the chat. Sorry about that. Let me pull up chat again. And then what you want to do is use this promo code webinar 90-day. Just get free 90 days for this online labeling platform. And there is no card or anything required. So just go sign up and then practice on your own data set. And then you'll learn how to export that data, bring it into Google Colab, and then train your own model on it. And you'll be able to build really cool projects just off of what we're going to learn tonight. It's really the foundation for a lot of computer vision problems, solving a lot of computer vision problems. Someone said it will show 30 days. Oh, but it's 90. Oh, yeah, I want to say that that was fixed, but we'll see. So it used to show, even if you use the 90-day promo code, used to say you still have 30 days unless you went into your account. Because that was, we never had a long promo code like this before, but I think that's fixed now. What this workshop is, so this is a hopefully a very friendly introduction kind of to computer vision and object detection. It's kind of designed where there's no previous experience machine learning. That'll also kind of help you as well, but I will be explaining things along the way. And then if you are confused by anything, just let me know in the chat. I will be monitoring the chat as much as I can as I go. We'll cover applications and kind of basic intuition around computer vision. And then we'll talk about how to label your own data. Then we'll jump into the code and train a model with a data set. You can't learn everything in 2 hours. This is a pretty fast-paced crash course in computer vision and object detection. But I think you can really learn enough to get excited about the field and even start building your own projects and solving problems today. So parts of this, depending on your background, may feel really fast-paced or challenging. That's totally okay. I think you'll learn a lot just by sticking through to the end and kind of finishing the project. And you can always go back and look at the code, and then you can stay connected with me, ask me any questions. Yeah, and the big part is keep going after, keep learning after this workshop. So, and I'll point you to some resources afterwards too. So a little bit about me. My name is Sage Elliott. I'm a machine learning developer evangelist at Sixgill. I'll put this link in the chat. We do a lot of really cool stuff with machine learning, computer vision, IoT, a lot of kind of computer vision on the edge, which is on smaller hardware devices, not back to the cloud. And we are also making tools to make all those steps easier for everyone else. And for about the past decade, I've worked in the software or hardware industry with startups and agencies, either in Seattle, Washington, which is where I am now, or also in Melbourne, Florida. And I love making things with technology. You can stay connected with me on LinkedIn, Twitter. I'm Sage Codes. You can go to sageelliott.com. It should have all my other links. LinkedIn, I'm pretty active on, so that's one of the best places to message me if you have a question in the future. About you, normally, when I was doing in-person workshops, I loved going around the room, having you introduce yourselves, but there's so many people here, we can't really do that. But I always like to, most people already kind of communicated in the chat where they're watching this from and kind of why they're interested in computer vision. But I wanted to set up some kind of extra space to stay connected if you want to. Tomorrow, I'm doing I'm just calling it like a happy hour event, but it's really just kind of like for people in the AI industry. If you want to kind of actually introduce yourself there, say what you're working on, that would be really cool. And there's really no structure. It'll just be kind of like, come talk about what you're interested in. I also have a LinkedIn group here that I'm working on. I mean, LinkedIn's a great place for staying connected with everyone. So putting a group together where AI professionals or just people interested in AI can join. And then also I have a Slack channel here that I'm always in. So if you're going through like the labeling platform or trying to train your model or something and you get an error or you find a bug or you just have feedback or something, I would love to hear it. And that's going to be the best place to give me a lot of technical feedback or anything would probably be in that Slack channel. Again, setup just for anyone joining, because I know people are always still kind of trickling in. Just need the modern web browser, a Google account for Google Colab. I'll paste this link again. So this is the sign up page for the Sense labeling platform that we're going to use. And then use this promo code webinar 90-day, and you'll get 90 days for free. And then to sign up again, there's no card required or anything. So super easy. And I recommend checking it out. And I also would love your feedback on it too. All right, so what is computer vision? It's a pretty big field, but I would really just kind of boil it down to how computers gain understanding from images or videos. And there's other types of data as well that could be considered or transformed into an image or video. So like if you think about audio, you've probably seen audio signals. That can be a visual representation of audio. So you could actually use something like computer vision to monitor audio for certain things. Like I saw a project recently that was monitoring for, I think, gunshot detections for poachers for endangered animals. So you could actually use computer vision to solve that problem. And this little example here, you can see there's all these trucks and it's drawing a bounding box around it, as well as kind of coloring in what it actually thinks is the truck. So this bounding box, if it was just doing the bounding box, that would be object detection, where we're localizing where that object is in the image and classifying it. So we're saying, hey, this is a truck and it's within this box. And then with this extra little pixel coloring, that's object segmentation. So not only does it know where the truck is, it knows what part of the pixels is actually the truck. And then we have a little extra layer here, right? It can tell if the truck is moving. So you can see, like, is this object moving across the screen? If so, then we'll classify it as moving and color it green here instead of red. So a little example of understanding an image or a video. You can see it's not classifying the cars, it's just looking for trucks in this case. So we trained a model to do this. So why I love computer vision, I think it's a really amazing interface in the world, and we're already doing really, really amazing things with it today. So many people already had really cool ideas or things they were excited about in the chat earlier. People are talking about medical industry, autonomous vehicles, all sorts of things, and all those fields are really cool. And there's like it's happening right now. People are building autonomous vehicles or making big changes in the medical industry. Real quick, kind of coverage of who uses computer vision. So here's some examples you've probably heard about before. In Seattle, we have our one of our small local companies, Amazon. I don't know if anyone's ever heard of them before. Just kidding. I'm sure everyone's heard of Amazon. In Seattle, though, we have several stores called Amazon Go or Amazon Go Grocery. You can let me know in the chat. Has anyone ever been in an Amazon Go before? I know they're in a few other states. I don't know if they're out of the country yet. But they're really interesting. There's no checkout counters. It's just an array of cameras, and I'm assuming GPUs, some sort of edge processing unit. If you look up, you can see kind of an array of stuff. And what it does is you walk in, you scan a QR code right now on your phone, it lets you in, and then you just go pick up whatever you want, and then you walk out. And the first time you do it, it feels like you're stealing because you didn't check out, but it keeps track of what you pick off the shelves. And if you put something back, it keeps track of that too. And then it charges you like after you walk out of the store. It's very interesting, really cool. And it makes a lot of sense right now too during COVID. You don't have to stand in line with people. You're not exposing other workers like a cashier or anything. They're also working on delivery robots, and you use computer vision to navigate sidewalks and roads, self-driving cars. They had recently bought a self-driving car company. So I'm assuming they're working on that. And then also they have so many images uploaded to Amazon itself. I believe that some of those teams use computer vision to look at those images and make sure that they're fine for the website. Google Photos. If you have a Google Photo account, you could type in like dog or something, it would bring up all the pictures of your dog. YouTube content and filtering. So many hours get uploaded to YouTube, and they have to be pretty good around filtering out content that's like copyrighted. And Tesla, self-driving cars, Facebook, face tagging. These are all probably ones you're somewhat familiar with, maybe besides Amazon Go if you hadn't been there before. But I wanted to talk about some other really cool computer vision applications, and people have already mentioned some in the chat. It's not just big tech companies that can benefit from things like computer vision and machine learning. It really is reaching kind of so many different fields right now. So we had talked about in the chat earlier, healthcare. You can use it for things like X-ray diagnostics, MRI scans, medicine research, manufacturing. This is actually how I got into computer vision and machine learning. Was I had mentioned I had worked in the hardware industry, and I was setting up product lines, and we had a really complicated part we were manufacturing. It was hard to say if it was good or bad. Like you could take it to different people in the office and get different answers back, right? Because if they just weren't an expert in what the quality level had to be. And so if you're setting up a product line somewhere, you don't know who's going to be doing the QA. So I thought maybe we could do this with computer vision and use an edge device to run a model on, and it actually worked pretty good. That was kind of my first introduction into the field, and I thought it was really exciting. So you can use it for quality assurance, throughput, supply chain, oil and gas industry, leak detection and safety. Agriculture is a big one. You can do like crop monitoring and animal monitoring. Construction's a big one for safety right now too. Like monitoring the site. Are people wearing all their protective gear? I saw a company working on self-driving tractors. I thought that sounded really cool. And then there's also GANs, which I think someone talked about GANs earlier in the chat. I wasn't able to answer them, but they're kind of a generative type of a computer vision where they can create their own images. So this link I shared in the chat has realistic looking faces, but none of those faces are real. Oh, someone said, can I repeat what got you into computer vision? It was solving a manufacturing quality assurance problem. So we had a really complicated part, and it was hard to detect it was good or bad with like a human, like having someone trained and having them cycled out. So instead we made a computer vision application to do it. Does anyone else have any other really cool, interesting fields that I didn't mention here? Because this is by no means all the fields. And it's really fun to see like what other people are thinking about. I saw someone post drones. That's a huge one, right? Like you can do aerial view footage and find interesting problems to solve that way. Like if you could detect forest fires earlier, that would be huge. I saw that there was a company using drones that was using drones and computer vision to look at electrical equipment, that's like mounted on posts really high, and do predictive failures to prevent some of the forest fires that are caused by things like that. That's really interesting. Someone said medical diagnosis. Yeah, I think that's a huge field, right? Like if you can, make our medical industry better, that's awesome. Someone said robots. Yeah, so many cool different robotic applications. Someone said wildlife apps. It's great because we're actually going to be building a wildlife object detector. And don't worry, you can use what we're going to learn to really use any type of object detection system. But we are going to use it on geese, so you might appreciate that. Someone said TikTok. It's actually funny. So like TikTok and Snapchat, those could be, and Instagram, those could be, huge uses of computer vision, because if you ever use a filter or anything and it finds your face, it's using some sort of computer vision to do that. Awesome. Love seeing all the answers. Really cool. You can definitely keep posting, but I'm going to keep moving forward. So computer vision and deep learning. Computer vision isn't always tied to deep learning. It's kind of its own field. But with the improvements that deep learning has brought to the field, like when you hear about someone using computer vision for self-driving cars and things like that, very likely it's using deep learning behind the scenes as well. But I did just want to point that out because they can be a little bit separate fields. There's a whole bunch of different stuff you can do just on image processing and finding areas of something or doing all sorts of stuff without deep learning behind the scenes. But most of the stuff you're going to be hearing about that's like breaking is probably using deep learning, because it really, really helped start solving these really complex problems. In other intros of deep learning, so if you've never done anything with deep learning or computer vision before, I'm just going to give you a very, very high level overview. Almost any other like intro will go probably much deeper into it, but I really want to get to the point where we're going to label our data and train a model and be really hands-on, and then you can kind of go back and fill in any of those gaps that you feel like you need. And again, you can't do everything in 2 hours, so cutting a little bit of corners, but you'll be fine. We're actually going to make something awesome. But I did want to share a couple of links with you if you wanted to look at kind of what a deep neural network looks like and maybe how it behaves, as well as for computer vision, the biggest thing in the field right now is a convolutional neural network, just kind of a different type that looks at images and does some kind of filtering and then will make predictions. And at a very, very high level, you can think of deep learning and most machine learning, and in this case, we'll think about deep learning and computer vision, where you have some sort of function you make, and you could think of this as a mathematical function, or you could think of it as a programming function. And what we do is we pass training data into that function and say, hey, in this case, we're talking about like a labeled data set. So we would give it pictures of cats and dogs, and we would say, hey, here's a picture of a dog, like learn some features about a dog. And adjust some parameters in your function so that if we give you another picture of a dog, you could hopefully make the right prediction. So you feed a bunch of training data, it's going to learn a whole bunch of parameters of what makes up a dog. So maybe it's like different ears, or its nose, or it's got snouts. If you're feeding cat versus dog, it would figure out, cats look different. Their ears are always smaller and more triangular. And we'll learn all these features. And then you could pass it a new piece of data once your model is trained and then get a prediction back. So you give it a picture of a dog it's never seen before, and then hopefully it would return a prediction of a dog. This very high level of kind of how deep learning works. A note on transfer learning, though. So with most popular deep learning frameworks and computer vision frameworks, you can almost always preload, or you can always load a pre-trained weights into your network. So these are neural networks that have already been trained for like a ton of hours on thousands of images. And so one, you can often take those in and they might be okay for your specific problem. Like if it's just detecting people and they happen to be okay at detecting people in your angle of the camera and stuff like that, you could load in those weights and say, hey, look for people, and it could spit out some output. But more importantly is you can use something called transfer learning. So it was already trained on a massive data set, and then we want to train it on something completely new it's never seen before. Well, it turns out that you can use a pre-trained model and then train it with new data, and it'll adjust parameters, but it already had so much knowledge built up of images and kind of what the world looks like that you can train it way faster on a much smaller data set. So you'll see tonight we're going to use transfer learning, and just in like not that many images, and it's only going to take a few minutes for us to train, we'll actually get a really decent object detection model. And so really just think of it as you don't have to start from zero. Oh, and my kind of casual rule of thumb, so if you're thinking about building your own project after this, which I really hope you are, and I would love to see it, by the way, is I always try to start with around a minimum of 200-ish images when I'm using transfer learning, or instances. So when we talk about building our data set, if you have one image and it has 2 animals in it that you're trying to detect, then that would count as like 2, right? But it can vary a lot depending on your data. So if you have a lot of variation in your data, you might need more than 200. And if you can't get 200, you should try train your model anyway and just see how it performs on 100 or whatever you have. And without the transfer learning, you would probably need thousands of images and a lot more time. So some types of computer vision, I'm just going to go through kind of the common types, just so you have an idea what's out there and what might work for use cases that you're interested in. Some types of, someone asked in the chat, where do I get the transfer learning weights? So I'll show you. That's usually built into whatever you're using. So if you're using TensorFlow or PyTorch, or tonight we're going to use something called Detectron 2, there's almost always an option for that. So I'll show you how to do it in Detectron 2, and it'll be a very similar way in PyTorch. So computer vision is a big field, and we're going to focus on computer vision with deep learning. Many of these types can also be kind of combined together or used with another algorithm or several algorithms to form various outcomes. And I'll kind of talk about this as we go. So first up is classification. You've probably seen this one before. If you've done anything with computer vision, you've probably done classification first. It's kind of the hello world of computer vision. So this is kind of what I talked about, where you would feed it images of dog and a cat, and then you would hopefully get a correct prediction. So in this case, this one was trained on an image data set of dog breeds, and then you feed it this picture of a Labrador, and it returned a Labrador retriever. So most tutorials will start here and really cover classification thoroughly. But I think getting out of this and doing things like object detection is way more fun and often more useful for real world applications. So object detection can classify and localize where an object is inside the image or video. So instead of just classifying, saying, yes, there's a goose in here, we can actually say there's a goose, and we're pretty sure it's right here. And there's another goose, and we're pretty sure it's right here. So you can, count how many things are in there. You can do like tracking on those objects, whereas classification really just returns what it thinks is in the image. And a problem with that as well is if you had, a goose and a dog in an image, maybe it would still return, only it's like, I know there's a dog in this, but I didn't know there was a goose in it. So object detection can really do a lot more, and you can use this output of kind of knowing where something is to do a lot of interesting things. And this is what we're going to make today. So we're going to cover how to make your own data set for this specifically. Instance segmentation, and also talk about as we go, because instance segmentation and object detection, building one or the other isn't that different. So I'll talk about how to build your own instance segmentation model as well, if you end up wanting to do that. Oops. So here's just an example. Instead of, remember when I talked about the trucks, it had the little box around it, but it also is classifying exactly where something is. So in this case, it's classifying pretty much the exact pixels of where the bottle is, and also trained where the water is. So you could do something like, measuring how full a bottle is by how many of water pixels overlap with the bottle. Feature point clustering. You might have seen examples like this, where you can do like pose estimation or facial mood prediction. Like if someone's angry or happy, often it uses something called a feature point. So you can see these little dots. It's measuring like, hey, this is where the hand is, this is where the elbow is, and then you train a model on all these different points, and then you can actually do things like, in this case, it's just yoga, and it's predicting what pose they're in. Image captioning with text. So you can caption an image, have like what's going on in here, and there's ways of training a computer vision algorithm mixed with some other stuff to have kind of a context awareness prediction of it. So instead of just saying like kite, girl, beach, it actually has some sort of context awareness where it says, well, the girl would be on the beach and they would be flying the kite, which is, I think, really cool. GANs, I talked about these briefly. This is actually some example. I was working on a GAN project generating architecture designs. And this is before it actually started looking like houses. But I thought that this was a really cool looking. It just looks like art. So I saved this picture. I thought it was awesome. You can read a little bit more about that architecture project on the other person I was working with. They have it on their website. We're actually working on a new version of that, which is kind of cool. I'm choosing a model. So there can be a lot of factors that go into choosing a model and ways to tie them together. But when you're just getting started, like if you haven't done computer vision a lot before, just kind of think about what's the problem you're solving and what's the outcome you're looking for. So if you're just kind of counting how many animals there are at a certain time of day or in a frame or something like that, then you could use object detection. If you need more pixel perfect interaction between something like this, you could understand that this is a mouse and that this is like a piece of food, and see when something is actually touching each other. You could use image segmentation. There's also a little bit more that goes into that too, where like image segmentation tends to be a little bit more accurate, and I'll talk about why when we actually get to the labeling portion. Any questions so far? I saw some stuff come up in the chat. I'm just going to pause for a second. Any questions? Anything you want me to reiterate on real quick? Someone said, will the slides be shared? Yeah, we can share the slides. I think they should go out with a follow-up email, I think. Someone said, where do you get the transfer learning weights? I think I already answered that there. Sorry, I might have scrolled up a little too high. Someone said you can download the weights from the place where you download the model. Yeah, I'll show you. It'll make sense when we do it if it doesn't right now. Someone said, what about grouping data like that to identify the geese as a gander? Yeah, so you could be like, hey, if there's more than one geese, or I don't know how many geese technically make up a gander. But yeah, you can 100% do that. And I'll actually show you when we train our model detection to do something like that wouldn't be that hard. We'll actually extract in an image or a video how many geese are in there, and you can print something out like, hey, there's this many geese. And then based on that, you could do some logic to it and say, you know, that that's a gander now, whatever the technical definition of that is. Slide just moved. I think someone had some lag. Someone said, will it be shared at the end? Yeah, that should be shared out at the end. Someone said, how does it know the beach is tropical? I think it's just trained on, in that case, probably trained on different types of beaches. And maybe that one looked tropical. Maybe it wasn't even correct. Someone said, how do you think transfer learning works for data that is structurally different? Like if it has different number of channels or not RGB image? That can, you know, it's probably still fine. There's different ways of starting with transfer learning and then doing different tuning for it too. One big thing that transfer learning is great for is actually picking up like edges of things. And so even if you're doing something black and white, it would probably be helpful, but it might depend on what your data is. But a lot of times the transfer learning, you might be a completely different type of data that it had never seen before. And oftentimes it still works very well to start with transfer learning just because it learned certain things like what makes up lines, what makes up corners, what makes up circles. And most of those kind of shapes come through in other pieces of data. So object detection in a gist. So what happens usually, there's different types of object detectors, and I'll actually share this link in the chat. So this goes through kind of several different types. Or this one might go deeper in the mask CNN one, sorry. But I do have links to share with the other types if you're interested after the talk to read them. But essentially what it does is it looks at an image once it's trained, and it will find kind of proposed regions where it thinks that something is in the image. So it would be like, hey, we think something's around here. And then it runs a classifier. So behind the scenes of an object detection model, usually there is still one of those classification algorithms. Like if you have done classification before, like a ResNet or one of those. And then it'll run a classifier around the area, find in this case, the goose, where it thinks it is, probably the best fit for it, and then kind of estimate where the goose is. So then it would draw a box around it. So this is kind of a high level version of it, and they all work a little bit differently. So you can read more about them later. So popular object detection methods. So here are the kind of the popular ones that I was talking about. They all work a little bit different. So single shot multi-box detector, or abbreviated to SSD. So it does object detection, and it tends to be very fast. A lot of times you'll see this deployed on kind of not as powerful hardware. So if you were training a model and you want to run it on a Raspberry Pi, you might end up using something like single shot multi-box detection. YOLO, you only look once, is good for object detection. It's also pretty fast. And then you have a mask RCNN, or kind of another version of faster mask RCNN. It does object detection, image segmentation, and it tends to do very high accuracy, but a little bit slower than something like single shot multi-box detection. And then we are going to use Facebook Detectron 2 tonight. So it's made by Facebook AI's team. And let me just click on this link real quick, and I'll just show this to you. So this is a framework by Facebook, and it uses PyTorch, which Facebook also maintains. And it's a framework that allows you to kind of easily train a model to do a whole bunch of different things. So today we're going to train it to do object detection. Like this, right? It's drawing boxes, but it can also do pose estimation. So you could label data with the pose, those key points. This is something called dense pose, where it can figure out where they are and then actually draw kind of 3D characters over them. And then here it's doing object segmentation. So you can see it's drawing, around the table, each individual thing on the table, kind of different objects in the background, the people. And then there's another version of this segmentation where it also draws the backgrounds in it. So this can be really good for context too. So if you're doing this on like an image from a self-driving car and you're running something like this, you could see, the background's a sky or a cityscape or different things like that, which is cool. But they make it fairly easy to kind of train all these different cool models, which is nice. And that's where we're going to use. And it's I think a fork of the MASCAR CNN, like we had talked about, where it can do object detection and image segmentation. All right, and just wanted to mention real quick kind of the full computer vision lifecycle. So we're going to talk about data annotation and the actual machine learning portion of it. And these are all very important steps and where most people kind of will do a lot of work in. But I just want to mention that you can think about, there's a lot of other steps that might happen in the real world or for your project. Is you might have to manage devices like edge computing, like managing something in a factory that's not connected to the internet, but still running a computer vision model. And data collection. So often, right, like we're going to start with some images today. You might have images from somewhere, but you have to collect that data from somewhere. And oftentimes it's from a camera for computer vision, or you're scraping the web or something for different image data sets. But that could be a big step alone. Like if you have a camera in a factory and you're trying to get data from it, you have to manage that data stream and then have it saved somewhere and then break it out in a way where you can label it. So then data annotation, we'll cover this, and machine learning. That's actually where we use that labeled data and then we train a model. And then after that, this can be a hard part too, is deployment. So you can have a model that's deployed, but now how do you run it on that camera that's maybe in the factory or outside? So this can be a little bit of a hard step as well. And then often you'll want to repeat kind of all these steps for continuous machine learning. So you might have environments change, clothing change throughout the year, and you want to make sure your model still is performing well. So you might need to relabel kind of, or label new images coming in and retrain a model. So if you were doing wildlife detection and all of your model is trained on geese in the summer at the park, and then you're trying to run your object detection on geese in the park in winter and there's snow on the ground, I don't think geese would stay in snow. Might be a bad example. But it wasn't trained using the snow as a background environment. So potentially it may not perform as well or can mess up versus the kind of summer background. So something to think about. We do all that on one platform. So if you have interests around that, you can email me at selliott@sixgill.com or just kind of schedule a demo. So right now you can't sign up for just all of those things immediately. There's some onboarding involved, but if you happen to be in a place where you need to do kind of all those steps in one platform, let me know. Or if you just need model building as well, we contract to build models for complicated computer vision problems. So you can let us know at sixgill.com or email me directly. So I'm just going to talk about some popular Python libraries before we get into the labeling and code, but we're almost there. So here's some popular ones. So PyTorch, it's a library from Facebook for machine learning, really popular in deep learning and computer vision. TensorFlow and Keras, that is Google's version kind of PyTorch. I forget which one came first, but they do very similar things. So you will see people often use one or the other or both. Some people tend to start sticking with one and it becomes their favorite framework for it. OpenCV, an awesome library for image processing and computer vision. NumPy is great at processing multi-dimensional arrays, which is actually how computers see images. And we could take a look at one when we get to the code real fast of what it actually looks like to Python. And Pillow is another great image processing library. All right, so we're going to talk about labeling now, but I just want to pause real quick, see in the chat any questions. How is everyone doing? Are you excited to look at labeling a data set? We won't spend too much time on it. Then we'll pop into the code and start training our model. But you have to let me know how you're doing. Okay, someone said, let's go. Just want to make sure that you're all still feeling good. All right, so I'm going to use that the product I had shared earlier, which was this. I'll share it in the chat again if anyone just joined. Oh no, copy URL. All right, so if you didn't, you can sign up here for this, and I'll walk through the steps so you can actually start making your own data set. And again, you should totally use this promo code because 90 days is quite a long time. And you could build some awesome projects in that amount of time. All right, so once you sign up, you'll have a page that looks like this. It'll be empty at first because you won't have a project. So you go to the sign up page, it'll send you an email. Once you verify your email, you can open it up and it will bring you to a page like this without the Goose project. So I'm going to show you how to create a project and how to do the labeling. And we're not going to label hundreds of images or anything. I'm just going to show a couple examples. So don't worry, it's not going to be like an hour of labeling, which is in the real world, it might take you an hour. All right, so you can hit create project and you just give it a name. I'll just call this, I'll call it AI Camp. Oh my gosh, I can't type. AI Camp Goose. I'll hit next. And so this is actually a really cool little feature where you can put project instructions in here. If you're just labeling your own data set, you probably don't need to put something in here. But if you're labeling with a team, because there's the collaboration features in here too, so you can have like a whole team of people. And often what happens in the real world, you have like a domain expert kind of come in and say how something should be labeled, because you as a computer vision engineer, you might not know how, what a certain tumor looks like or something like that. The medical professional should tell you and come up with a criteria of what makes one of those for the labeling process. So you can put all that in here. You can type stuff. You can insert images with markdown. So in this case, I'm just going to say label each goose with a bounding box. That's kind of the rectangle label for object detection. Say label. I'm just going to hit save. You can hit save with nothing in there too, but I just wanted to show an example of it. And then from here, we are going to upload some files. There's options. So if you are storing data online at Amazon S3 or Google Cloud Storage, you can connect those here. We also have a CSV and a search API. So if you just wanted to grab a couple pictures of a dog or something, you could hit search, say dog, and it would return some images. But here, I'm just going to upload a couple pictures of a goose. So I'm going to hit add assets from the files. And let me just do like 4 here. So I'm just going to select what images I want to upload. And this one, maybe that image had a problem, but these ones are uploaded. If I needed to, I could hit add set, upload that image again. It might be, I just re-downloaded some images and stuff, so it's possible I did something wrong or corrupted an image. So once you do that, you hit create a label schema. I'm going to hit add label. And I'm just going to say goose here. And then the default label here is rectangle. So that is what we want for object detection. And I'm going to hit save. You can change a color. This is just for you. So if you know the backgrounds that your objects are going to be on, you can choose a color that's a little easier to see. So I know that a lot of my geese are in a green background, and a green label might be hard to see. So I'm going to have a red one. I'm going to hit save. And then I'm also going to make a second one just to demonstrate how you would label for the image segmentation problems. So I'm going to call this goose polygon. And from here, I just want to select this polygon type of label. So we'll hit save. Now we have both of these. And then I'm going to hit start labeling. And this will bring you to the labeler. And I really quickly want to note, so as you label images, this filter is automatically applied. And by default, it says that, or it'll show only the pending ones. So you can go here and hit all images if whatever reason they are not showing up here. It might be because this filter is on if you came back and visited your project. So to label a goose for object detection, we're just going to select this rectangle label, and you can see these little crosshairs come out like this. And we're going to draw a bounding box around it. And here's one. You want to be pretty close to, like where the goose is. But it's okay if you have a little extra space, especially just for kind of a hobby type project, And you'll find as you get more into computer vision, labels affect your model a lot. And so you can really come in and tighten them up or something if you needed to in a production ready model. And that's how we label a first image for object detection. I'm going to hit submit here. And so it applied those labels to the image. Was that easier than people thought? Because I know when I was first getting started computer vision, I always thought it was going to be way harder to label data for computer vision. It turns out if you have a good tool for it, at least it's not that hard. And I'm going to show you real quick. So if we were doing segmentation, we would select this goose polygon. And instead of drawing a box around it quickly, what we have to do is draw lines around it. And this you want to be as close as possible. I'm not going to spend a ton of time doing this super accurately, so I might do this very poorly here. But just to show an example, you would do this. And this is labeling polygons typically takes a lot longer than doing object detection. So know that if you do want to do image segmentation, you might have to set a little bit more time aside for the labeling, or outsource it for someone else to label it. Which we also do a labeling service outsourcing. So if you do have a big project and you need help labeling, let me know. Here we're going to go around, and then you get to this corner and drag it to that node, and then you can see it connects, and it kind of highlights around the goose. I did a pretty bad job here, but if you ever want to come back in and adjust your label after, you can hit the X and click the escape key. Will kind of exit out of this label you selected, and then you can also drag these little nodes around and clean up your labels if you wanted. But that's a lot more time, right, for image segmentation. But it turns out that if you do image segmentation, your model is usually more accurate because it really gets way more of the background and everything cut out and understands better what the object you're looking for is. But I'm going to show you a really cool feature that we have. And so you saw how long that took, and I did it pretty poorly. Whereas like a lot of times if you're doing labeling, you'd be much happier doing this, right? Am I correct in assuming that? Or do people really like drawing, tracing things? So if you're going to do polygon labeling in our platform, what you can actually do is hit this little button here, and it says Smart Poly, and select the polygon label, and then you can see it brings up the crosshairs just like drawing a box. What we want to do is draw a box around it. You want to be usually as pretty tight to the object as possible. And boom, it automatically snapped polygons on. That's pretty awesome, right? And it did a pretty good job here. If it messes up at all because not everything is going to work exactly perfect on every data type, again, you can select those polygons and then do any adjustments you need to. So even if I had to do 1 or 2 adjustments, that saves me a ton of time of labeling for image segmentation. So then you would just do that across all the objects that you want. Something to note too when you're labeling your own data set. So if you're labeling one thing in your image, you want to label them all. So if I just labeled one goose and I exported this data set and was trying to train a model on it, it would be really confused because we would be telling it this is a goose, and it would try to extract those features out of this rectangle. Or rectangle, and but then it would see that this goose is over here, and it would say, well, it has a lot of the same features, so I'm really confused, and it probably wouldn't learn very well. So if you're doing object detection or anything, or the image segmentation, any type of labeling for instances, you always want to label all those instances in your image. Otherwise, it really might throw off your training. So we would just hit submit on this. And we'll just do it for this last image. Boom, boom. Well, and the smart polygon feature, that's the first of several kind of AI assisted labeling features that we're coming out with. So soon, probably in your trial period, we'll be coming out with something called Next Label, where it'll be, you can label one instance of something, or like one image, all the instances in your image, and then go to the next image, and it'll do object tracking and kind of apply those labels to the same objects, which will be really cool. And that'll really speed up labeling time as well. So I'll hit submit. And I think that was my full data set here. So this brings us to this review tab. So you can go to all those tabs up here. You can go to a little dashboard. It'll give you some insights about your data set. It says there's 6 geese. Remember, because there's like 2 instances in each photo. Project details is where you do things like change the name. You can add more data to this too. So you could get started with, 10 images or whatever. And then as you get more, keep adding them in here, and you don't have to relabel everything, just the new images. Label definitions is where you add labels at or edit the name or anything. Labeler is where you do the labeling. It says no data because remember I talked about that filter. So automatically it only shows the pending ones. But if you want to look at all of your images, just select all images here, and then you can navigate and look at your labels again. And then there's a lot of other cool features too that you can explore around in. Like if you had images that are hard to see, you can adjust things like lighting. This doesn't actually save the changes to your data set or images. This just is for you to do the labeling because sometimes things are hard to see. You can copy labels from a previous one, which is nice. So then if you go to, it might not work because I already labeled the other one, but if it would bring those labels to the next frame. So that's really useful if you're doing a video that things aren't moving far. So if you had a video of me walking across the screen and you don't want to label like every rectangle, every single frame, because I didn't move that far. I didn't want to drag a fresh one. You could just hit auto add from previous, and it'll just keep adding the same label, and you just shift it over where it's appropriate. So we submitted our things. You can actually go and do an extra step of approve. That's really more for if you're working with a team. But now we want to export our data so we can use it with our model. So we go to this review tab, and we're going to hit export project here. And we have different formats. So these are all the major ones that you'll probably need for computer vision. We kind of have our generic JSON document that you can parse out and do what you need to with it. Then we can export to create ML classifier, create ML object detector. Create ML is Apple's kind of a computer vision thing. Coco, I often end up working a lot with a Coco data set. It's a really popular one, and that's what we're going to use here. But we also support YOLO, Pascal VOC. So depending on what your model is that you're using, you can kind of probably get the correct format here. And what I want to do is you'll notice these 2 checkboxes. So this is so that if you're working with a team, you could have someone label all the data. You could go in here and you could hit, I approve all these. These all look correct. They'll then be approved. And then you can export project. And by default, it will have the checkbox that's approved. And it disappeared because they're all approved. So it'll just export everything. But you saw the other checkbox before where it said export submitted. So if you're just labeling by yourself and you didn't want to do this extra approve step, just hit that checkbox that said submitted and hit export now. We also have this train test split feature, which is really nice. So if you've done any machine learning before, you know that you often want to break up your data set. We'll talk about this because we're going to use these 3 data sets to train our model and test it. We have the training data set, which is usually the largest one. Most of the data, as much data as you can, you want to give to your model to learn from. Then you have a validation data set, and this is used while you're training your model. You kind of want to run it on some data it's never seen before to make sure that it is learning what you want it to learn and performing well against data that it never saw, right? Because sometimes models can kind of overfit on their data. So it might say the accuracy is doing really well while training, but then you give it new data it's never seen before, and it might perform horribly. So you kind of want to, while you're training, because it can take a long time, you want to feed it some data, see how it's doing. And then once you're done training, you want to run it on a separate test data set. And that's because as you're using this validation data during training, you as the human might be adjusting parameters, not the model, but you might change learning rate or different things that would make a model perform better. And so you don't want to overfit your hyperparameters to your validation data set. Or if you did, then you're essentially double checking again with a separate test data set. So these test and validate are things the model never actually sees. The validation is for you as the human in the loop during the training process to make changes. And then the test is something you should save for the end after you've trained your model and had it working good on your validation. You then do a double check on your test data set. So we'll hit export here. I like to randomize the order of my images too, just so it shuffles them up and then splits them out. I'll hit export now. And then what it'll do is it'll send me an email, usually right away. And then in a little bit, you'll get a little notification here. And you can hit this download export, and it'll just download from your browser or from your email. It's up to you. Sometimes I've noticed just right now, like the email might be there. If it takes a minute or something for this to come in, just go check your email and get the export from there. And that's kind of labeling in a nutshell. How do people feel about computer vision labeling? It's very, very important. And I feel like a lot of tutorials, they don't talk about it. And then you kind of get to the point where you're ready to go out of tutorials and you don't know how to build your own data set. So I hope that this was very enlightening for that. And kind of all the, all the things I talked about here too are applicable across, different platforms. So hopefully this is insightful for you. So I'm going to go back to these slides. I think Bill wanted to do a quick check too. So how is everyone feeling right now in the workshop, content-wise? Because we're about to get into coding in a second. Bill, do you want to put that survey in or the poll? Well, see if a poll pops up. It'll ask you how you're feeling, I think. But cool. People are saying they're feeling good. There's 83 people. But I just want to do a check-in, make sure that you're good. I didn't lose you. Someone asked, what was the export format? So the export format was Cocoa. And that's because, so a lot of frameworks will have things like a function that can already work with these types of data sets. And so Detectron 2 has one that's built in to look at Cocoa data sets, this specific format of a data set, and parse through and get the images, get all those annotations. Most of them will have something like that. And so being able to export directly to Cocoa is great, because I think most of the major frameworks have something to work with Cocoa. And some also might use YOLO or Pascal VOC. So real quick, this is kind of what the export looks like. It'll have like an image. This is a long JSON file, and apparently it's just one line for me right now. Oh no, my VS Code was frozen, but it's my screen's not frozen, is it? All right, cool. I think just my VS Code froze, but it's just a long file that has like the image path and then kind of where those bounding boxes are drawn on the image. Someone said very insightful. Usually in courses they go to ML methods right away, and only later you learn that 80% of the time is on data preparation. Exactly. So that's where I was like, I feel like when I was learning, there was so much emphasis on just like, here's how to train something really quickly. But they always gave you pre-labeled data set, and then you want to go build your awesome idea. And then you're like, wait, how do I do this? And how do I get my data after labeling into something? So, all right. Is everyone ready to do the model training now? And I think you'll be surprised kind of how easy that is too. And I'll give you a template, like you can save your own copy, and then we'll walk through what we have there tonight. But then I really encourage you to go label your own data set and try training a model on that, because you'll learn so much from really doing projects like that. Is the best way to learn, in my opinion, is just kind of learn by doing. And you'll be surprised how many problems come from kind of data collection and labeling too. Just again, for anyone who didn't sign up, that's the sign up link. And then again, use that promo code webinar 90-day for 90 days. All right. So I'm going to share this link. This is to the Colab notebook. So we're getting ready to code and train our computer vision model. I'll share this in here. Also, people want to keep track of this link. I know often people come in even later, and then they might ask for it again. If you keep track of that and you want to share it, if anyone asks, that'd be awesome.
Hey, Sage, sorry, I just come back. Do you want to launch the poll? It's a good time?
Yeah.
Okay.
A lot of people said they were feeling good, but Bill's just going to put a poll in,
awesome.
in there.
Okay. Just quickly using this poll.
Yeah, so you could vote. This is good, no, or you're completely lost. Seems like a lot of people, at least in the chat, were saying that they're feeling good. So it is a good time for that poll because we'll do a little bit of setup. again.
You can see the result, right?
Yep.
Okay.
Cool.
Okay.
So
seems like a majority we are doing pretty good.
Cool.
A couple a bit lost. Maybe later on you can.
Yeah, you can always connect with me too and ask me any questions. And I know, if you've never done computer vision before or anything, again, we're covering a lot at a pretty fast pace. So totally get it if you're lost on some things.
Okay. Awesome, great.
Great. So open up this link, everyone, and you should get this page. Let me know, did this show up for you? Yes, cool. Awesome, great. So once you're here, what you want to do is hit File and save a copy in Drive. So go to File and hit Save a Copy in Drive. And this is going to contain all the code we need to understand how to train our object detection model and then run it on images and video. And again, because people are awesome, said that it worked, I'll just share this chat, share this link in the chat again for anyone who didn't click on it yet. So here, save a copy in Drive. And what this is Google Colab. So it's essentially Google's way of hosting a Jupyter notebook, which is a really popular tool in data science. It allows us to write code, documentation, output the code see the outputs from the code and like visuals all in one place. So it's really awesome for experimentation, really great for a workshop too, because we can have some code, you can make changes to it live and you can run it. Colab is also really cool because they'll give you free GPU access. And because you copied from mine, it should already be set up. But if you're ever creating your own Colab notebook and you want to have access to a GPU to train something for deep learning, you can go to Runtime, change runtime type, and then select from here what you want. So you can have none, you can have GPU. I'm not sure if they've changed the terms or anything, but it used to be that I think they gave you up to 12 hours of GPU time a day, and which is awesome. But it does vary which GPU you get. So sometimes you get a more powerful one, sometimes you don't, but it's awesome to have for free. So yours should be selected GPU. You don't have to change anything right now. And a TPU is a tensor processing unit. I believe that's Google's proprietary kind of hardware for running things like deep learning. Someone asked how to get to this page again. It should be the link in the chat right above your question. So just click on this and then hit make a copy, save a copy in Drive. Right here, save a copy in Drive, and then you should have your own copy. And this is yours, so you could bookmark it and come back to it. And maybe you want to bookmark that original link, because if you do change a lot of stuff in here or break it, you can always go back to the original one, save your own copy again. And I try to keep this one up to date as well, because Colab will sometimes update pre-installed libraries and it could break something, and I try to go in and fix it when that happens. So this one, if you bookmark it, will be the most up to date. And so if you double click on this text cell, it'll come up with a view like this. You can add text. You can write in a format called Markdown. Then you can hit Shift Enter, and that'll bring back kind of this formatted text here. And then we have code cells. So these are these gray kind of cells here. And if you hit this play button, this will run the code. The first time you run a code cell, it's going to connect and kind of make an instance for you. So it can take a minute. But once it does that, all the other code cells should run pretty instantly. So go ahead and run this. Prints out hello world. We get the output down here. And then if you ever want to make a new code cell, you can hit this plus code. If you want to make a new text cell, you can hit this plus text. And you could do this right now if you want to add notes or anything to it. A cool thing about Google Colab as well is it's not just a Jupyter notebook. It's actually a whole little instance, an Ubuntu instance. So if you're familiar with anything like bash commands, where you can do like ls to list everything in the directory, you can actually do that here. Don't worry if you're not familiar with the command line. I just wanted to illustrate that you can run these commands. And to run a command line command, you just begin the command with an exclamation mark. So ls is it lists everything in the directory. This is just showing that there's a folder called sample data. And we can do here as well, and we'll go more into this in a little bit, but if your table of contents isn't open, you can hit this little menu here. And then you can hit this folder icon, and this will show all the folders and data that's in your instance right now. So let's go ahead, and we're going to install the dependencies for Detectron 2 in our instance. So here, this is just going to install PyTorch 1.7 and CUDA 101, which is the interface to the GPU for PyTorch. And then a library called Torch Vision, which is kind of computer vision stuff for PyTorch as well. And just to note, so it says requirements already satisfied because all this was actually pre-installed, but I left this in because PyTorch often updates, and then Google Colab will update, and then it might break everything. So right now it says requirements already satisfied, but you might want to run this if you come back to this in a month or two. We're going to install PyYAML and PyCoco tools because we're working with Coco format. We need it for Detectron 2. And we can just check our PyTorch version is 1.7. Again, because this might break things in the future if they update automatically. Hopefully it won't anymore because I added this piece of code. And then here, we're going to install Detectron 2. So we say pip install Detectron 2. If you're new to Python, pip install is how you install libraries. And we pass it this URL. And it's installing all these dependencies and then installing Detectron 2. And a lot of stuff's already pre-installed. So I didn't mention as well that Google Colab comes pre-installed with most of the major machine learning libraries. Here I'm installing this version of Pillow. I think someone posted there's a bug in the chat. Looks like they're moving ahead. Make sure you install this version of Pillow because I actually think that is what causes it. That's why this is here. So I think it needs this version of 7.2 because they had updated a library in the past. Pillow, remember, is an image processing library. And then here, we're going to install some Detectron 2, like we're importing it, some typical kind of methods from there. So we'll talk more about these as we use them. These are just things to train our model. And then some other common libraries like NumPy, OS, CV2 is OpenCV. And OpenCV always has a problem with notebooks. So Google actually has their own little function here called CV2 imshow. So we can actually display images using it without it breaking. Because if you do it locally on a notebook, I think it often breaks. So did this install for everyone? Just want to make sure. Someone said, what about restarting the runtime? So if restarting the runtime will get rid of all these installs. So every time you come back here, you'll just want to run all these things again. Someone said links to resources. Not sure which one you're talking about, but there's a lot of links at the bottom. Almost all the links for resources are at the bottom. Oh, someone said, what about restarting the runtime like it says here? So it says this, but it's fine. I don't know why it still says it. So they're actually in our runtime right now. We don't need to restart it. Thank you for clarifying that. Yeah, I should have pointed that out. So it says you need to restart it, but you don't. So just keep going. So mainly if this worked for everyone, then hopefully we won't have any errors. So people were able to install, right? And then import. All right, so creating a data set. We already talked about this. I just linked to it again here. So if you didn't sign up tonight and you want to come back, those links are right up here. Same with the promo code is right there as well. And sense data annotation. I linked to kind of the sense page, and you can read the docs here. And then again, the Slack channel is right there if you want to connect with me and ask me any questions. So I'm saying torch not defined. So if you get anything like that, chances are you didn't run one of the cells above. So make sure that you don't miss one of these. So this is the one where we installed torch 1.7. You may not have run it. So if you're getting an error, it says like torch not defined or something like that, you can go back to the top and just rerun all of these pieces. That's a common thing. I do it all the time too, like if I just accidentally skip something. But just make sure you're not skipping a code cell as we follow along, because that's most likely what's going to be causing an error for you. All right, so we have our labeled data set. For this workshop, I am cloning from GitHub. So I essentially just put that Goose data set that you saw me label an example of. I put it on GitHub because it makes it really easy for you to get it into your workbook for this workshop. But what I would do is I would get my data export, And there's a couple ways of getting your data in here for your own project. So you could go to your folder and you could go to all of your data. So you get these JSON files and images. And what you want to do is you could just like drag these into here and they would upload. But what I'd recommend, because if you do it this way, where you drag the folders in to here and they upload, they'll be there for this instance. But if you ever have to restart, like if you shut your tab or you get disconnected for some reason, that data won't stay there. So what I recommend is saving everything to your Google Drive and connecting to Google Drive. So what you do is, remember, if you don't have this open, you can click this one of these icons, this little folder icons. This will show everything in here. So we can see we have our cloned data set from GitHub. But what I would do is hit connect mount to drive. This will connect to your Google Drive. So you say, yeah, I want to do that. And then I don't know if anyone uses Google Drive a lot, but it's where you can save like all of your data. So you could upload images, you could upload JSON, you could save models to it. And then if this instance gets disconnected or you need to restart something, you can just go in and reconnect to all of your data. So I have this called ML and then run, and then I have some stuff in here. So like you could just go here and see that I have my Cocoa data set and my images are here and my JSON files in there. And I'll show you, link this in to the data set right here. But just wanted to say, if you plan on doing a lot of training or something that might take a long time, I would definitely suggest that you would put data in Google Drive. But if you're just playing around with it and you don't really care if your data stays forever, you could totally just click and drag everything into your folder or into this area. So here we're going to now take that data set that we labeled, put it in a format where Detectron2 can use it to train a model. So we have this function called register Cocoa instances that we're taking from the Detectron2 library. And we just say, hey, register Cocoa instances. We give it a name here. So this is the name of your data set. So in this case, this is like from their documentation. They just call it my data set train. You could name it something else. And then we pass it the JSON file. So remember when we did the train test split, we got 3, or maybe I guess I didn't show it, but we got 3 JSON files, one for the testing data set, one for the training data set, and one for validation. And then all these contain paths back to the images, and they're all stored in this image folder. That's what the exported Cocoa data set looks like. So we want to pass in to our train data set that train JSON, which is going to reference all the correct images to train on and the bounding boxes for them. So then here we reference where those images are. And just as a quick note, and this might vary. So if you used a different labeling product or something, just make sure that the paths are aligned, because in here you can see that the path here says it's in an image folder and then the image name. So if you had, like, it's easy to do this because you think, oh, all my images are in there, so go look in that image folder. But the path in the Cocoa data set then is looking for another image folder in there, and it'll give you an error later. So hopefully I just saved you a couple hours of time of troubleshooting if that ever happens to you. So we do this for the training data set and the validation data set and the test data set. So we got 3 of them in here. And if we looked in here, this is where our data set is. So you can see there's images with all the images, and then 3 JSON files that contain the data to train on. And it's really convenient having this register Cocoa instances because it actually makes it way easier to just bring data in. If you don't have like a Cocoa format or something that your framework is made to kind of discover or ingest quickly, you have to do a lot of extra work usually to get your data in. So you can actually read about that in the Detectron2 docs that are linked in here too. And then here, real quick, we just always want to check that our data set is reading correctly because you never know. I've done this before where I thought I was reading my data set correctly, and this we probably are because it's using a pre-built function. But you might have some variable wrong somewhere, and the bounding boxes could be like drawn in the wrong places or something like that. So here you can see that the geese are labeled and the bounding boxes look correct. What's happening here is we're just making a variable, my dataset train. We're using something called meta catalog, passing in our dataset. That's essentially getting the like label classes, so like goose from that. We're creating a variable called dataset dictionary, and we're passing in again that training data set. We'll look at what this looks like, but essentially it's a dictionary in Python is a format of saving data. And you'll see that it contains all those things like the URLs to the images and all those data annotations. And then we're just doing just 3 random images. And if we run this again, we should get 3 random ones again, 3 different ones. And so we're reading our image with OpenCV. We're using something called Visualizer from Detectron2 that easily plots out these visualizations. So we don't have to create our own visualization library just to kind of check on this. And this crazy little code is actually inverting the colors because OpenCV by default does blue, green, red, but almost every other library does red, green, blue. And so you actually just kind of have to invert the array. And I can actually talk more about this later, but that's what that's doing in case you were wondering. And then we're just drawing the visualizer, these rectangles out, and then displaying the image with the visualization on it. So keep going, looks like good. And this is what the dataset dictionary looks like. So it's just, right, this is all the data from our Cocoa instance. So you can see that there's this B box. This is the bounding boxes. So it's a corner for each triangle. And then our model is going to look at the data, essentially the pixel values within this rectangle and learn what a goose is in this case. You can see that there's the path to the image. All right, so training our Detectron2 model. I'm going to go ahead and run these code cells because it can take a little bit to train. But it shouldn't take that long. So let's run all the code cells and then I'll come back and talk about what's happening. So run this one, and let's just make sure that it gets started. Should give us some output in a second. Okay, we got some output. Everything is going fine. So I'm going to go back and talk about what's happening here. So this, you actually don't need to do this code cell if you're not running a validation data set. Detectron2 doesn't have a super easy way of running that validation as you're training. Like I was talking about, you kind of want to see how your model's performing on data that it's never seen before. And so this class is a way to do that in Detectron2. So we're making a class with a function. You can read the documentation again in the Detectron2 docs if you want to learn more about it. Or read this blog post above. It's a pretty good in-depth blog post about creating different validation types for training. So if you're curious, go to that. If not, just don't worry. This is a way that we're loading in that validation data set. So as we train our model, we'll get some feedback and see how it's learning on data it's never seen, or how it's performing on data it's never seen. So here, this is how you set up the Detectron2 for training. Is you use this config. We say CFG is equal to get config. It's kind of like a config node thing. And then we pass it in with all these different parameters. And we'll tune all these different parameters based on what we're doing. And I'll talk about each one because some of them are important to know when you're training your own data set. And I do have comments by each one. So hopefully that helps you out if you forget. So here first, this is kind of just initializing the model or parameters. And then we say config merge from file modelzoo.getConfig file. So this is where we're actually getting the model. So we want to do object detection. So they have a pre-built model for object detection, and it's under Cocoa detection, and then faster RCNN. We had talked about that being one of the high accuracy models. And then there's some other little information. So you can have larger ones and smaller ones. I think 101's the biggest one that I remember, but you can get lighter weight ones if you need to deploy on something like an edge device. So I have some notes up here. If you're doing image segmentation, what you'd want to do is copy this and replace this with that. And if you labeled your data with polygons, you'd actually be ready to train your image segmentation model instead of the object detection. So pretty similar. There's just a couple little things to change. Here we're passing in our train data set. Remember, we named it my dataset train. If you name it something else, make sure you change this to whatever you named it. Oh, and make sure you have this comma at the end. One time, this took me some time to figure out, but because it expects it to be a tuple, I think you might be able to pass in multiple data sets or something. And that's just another data type in Python. So if you don't have this there, it confuses it and it'll throw an error, and then you have to troubleshoot it. So again, hopefully I saved you some time there too. And then we have our data load num workers. If you've worked with PyTorch before, that's something in there that you can adjust for kind of multi processing, like depending on how you want to train it on multiple processes, you can do that. But don't really worry about it. You can just leave it 0 for now. It's more just kind of an advanced thing. Here we have model weights. So this is the transfer learning part. Someone asked, how do you get those weights I was talking about? If we didn't set this to this, then we'd be starting from 0. And it would take us a lot longer to get a good model. So you just have to make sure that this weights is the same as whatever you defined your model up here. So if you change this, that image segmentation one, you also need to change this here. So this is defining the model we want. And you can go in and go to this model zoo, this link over here. So they call it a model zoo. They have models to do all sorts of things. So you can go there. If you're trying to accomplish something specific, they might have a pre-built model. So if you're doing like the SSD, the single shot multi-box detection for object detection, they probably have a pre-trained and pre-made model for that you can grab. And then you just paste these variables. Images per batch, so this is images per batch per GPU to process at a time. Like it's going to load in this many images and then start learning from it. This is the base learning rate. Learning rate in deep learning is kind of just a hyperparameter for how it learns during something called gradient descent. And this is a pretty good one that you can probably just leave like this for most of your hobby type projects. But if you realize just it's not learning from something very well, or it's not performing very good, you could look at adjusting this learning rate. So maybe you go a little bit smaller, maybe you go a little bit bigger, and you can also just look up more about learning rates and when and how to adjust them. This one will probably be pretty good for a lot of the types of data. And then you have this iteration. So this is how many cycles it's going to load in all those images. So 300 is not that long. Like I'm already done training. Yours might be training a little bit longer because you maybe didn't get assigned as good of a GPU or something. But we're only going to do 300 iterations or epochs. So it's going to look at each image 300 times and learn from it. And hopefully we'll learn what a goose is. And then this is some setting you can put like the max instance per image to load in. I don't think you really need to worry about this unless your image has like hundreds of annotations per image or something. Maybe you'll need to mess with this. And then this is a very important one that you will want to change depending on what you're trying to do. So this is how many classes you have. So in this case, we only labeled a goose, right? But if you had a rectangle for a goose and a duck, then you would change this to 2. If you had a goose and a duck and a pigeon, that would be 3, and so on. So just remember to change this, because otherwise you can train your model and then get some weird results. And I've definitely forgotten to do that a couple times in the past too. You'll just have to come back and change this. And this is creating output directory called output. You can see that right here. We just saved our model and some other kind of data here. And then this is how we're running the validation data set. So we pass in this test data set, which is our validation data set. And then we're saying every 50 cycles, run our model wherever it's at on this new piece, this data that's never seen before, and then give us some results back. And I'll show you what that looks like down here. And we're making a variable called trainer, it's equal to my trainer. And that's just the way that the model gets trained in here. And then you also have some options, like if you were using a model that you had already trained before and you want to reload that model in and then keep training it, you could say resume is equal to true. So let's look at this output. Also, don't worry, that's a lot. If you've never done deep learning before or anything, some of this you might be like, what is that? Don't worry, and don't be scared of it. I think it's all kind of stuff you can at least learn an intuition about very quickly. So let's look at our output. This kind of crazy looking text here is actually an architecture of ResNet, which is the classifier and the backend for the object detection model that we chose. So scroll down, it's a lot of text. And then you can see it gives us some information. It said, there's 260 instances of geese that we're learning from. Some other stuff. And then here you can see it's running the validation data set for the first time. It's looking at 37 geese that it's never seen before, and it's trying to classify and locate where they are in an image. So because it only did 50 cycles, it's probably not going to be good at first. And we run validation because we want to see, okay, we expect it to be bad at first, and then we expect it to get better and better the more it trains. If it doesn't get better the more it trains, then something might be wrong with your model or data set, and you'll have to figure out what. So here it's putting in all these metrics. I have a link a little bit below this that talks way more about like in depth on what the metrics are. So we won't go super in depth. Just know that so AB is average precision, and we want these numbers to go up. And there's different ones where it's like different thresholds at, so it's saying if it's only 50% confident it's a goose, it's doing pretty good right now. But if you put the threshold to 75, it's not doing that great. And then the average precision between everything really is not that great at all. But that's okay because this is our first kind of 50 cycles, and we expect it to get better. So really, you just want to see these numbers going up. And it is. It's looking much better, right? Just after 100, it's like 150. This looks really good already. And this was our final one. So this is 300 iterations, and our average precision's pretty okay. We could maybe train for longer, and it might get better. And then I'm going to run this cell. This is the tensor board. So this will kind of show some metrics of training. And I know that for some people, this won't work potentially. Some people during workshops say it won't load for them. So I apologize. I don't think there's a fix for it, and I'm not sure what causes it. But you can wait a second, and then you get this cool graph like this, and it'll have kind of those AP, those average precision metrics. We can see they're still going up too. So if we trained our model for longer, it would probably perform even better here. So maybe like 500, would be good. And let's scroll down. We can go to some other metrics. We can see like our false negatives are going down, our class accuracy is going up. All these kind of metrics aren't here. So if you want to look at training results, you can do that in your tensor board here. All right, so let's get ready. I see some stuff in the chat. I'm going to keep going just because we're a little short on time, but I will be hanging out. So if you have any questions and I didn't get to them, please ask again. So I'm just going to keep going just so we make sure that we can get through this, which I think we can. I'm just going to stop a little less for questions. So I apologize. LS output, that's just listing the directory of our output, so you can also look visually in here. I use this a lot. I'm a much more of a visual person, but I know some people really like working in the terminal, seeing all the text output. Again, you can run those bash commands in here. So we see our model final.pth, that's the PyTorch model. And what we want to do now is we're going to load our model in and run it on some images and video. And like I was saying, you could output your model to Google Drive, or if your model's trained here, you could then drag it into a Google Drive folder and save it there, for eternity. And then what you want to do is just go to wherever that model is. So let's say I have a trained model. I was doing like a dummy project with Candy, and I have a model right here. What I want to do is just copy this path. And then instead of saying model final path here, I would actually just change this whole part to your path of the model as a string. So it would just be this. But first, let me run this. Someone did say real quick, even though I said I wasn't looking at chat, but is this shared? Yeah, so do this and make your own, go to File, save a copy in your Google Drive. All right, so here, this we're going to set up the model to run it, and it's very similar to training it. So we have this config variable again, and then we're also pointing to the same model that we trained on. This is very important. If you point to a different model that wasn't the architecture you trained on, when you load in your trained model that you just did, it'll throw an error. So make sure this is the same one that you did. So again, this is great for object detection, but if you do image segmentation, you did it at the training, you'd want to train this text, or you'd want to change this text to that one above, to the image segmentation one. Then we point it to the path of where our model is saved at. So again, this is just in that outputs folder, model final path. Then we're going to give it a test data set right now. And then we're going to say how many classes there were. Again, this is important. If you were training on something with 3 classes, you would change this to 3, just like you did during training. So really all these things, you want to make sure they're essentially the same as training, except for you want to load in your weights, not the transfer learning weights. And then here, this is a thing you can play with. This sets the threshold, so it'll only draw and return the predictions. In this case, if it's 90% confident that it's a goose, you might do something like you only want it at 70%. You're okay with that. 90%, you want to be very sure that it's a goose in this case. So if you train a model and you're just not seeing anything returned on the image, you go back and change this to like 50 or something real quick, and it'll probably draw a whole bunch of boxes, but you can make sure that it's actually learning. And then we're making a variable called predictor. And this is where we're going to feed images now to our predictor, and it'll return the model output, which we'll see what that looks like. So go ahead and run this. Oh no, what did I do? Oh, I made a mistake, I think, when I was showing you how to change it. So I accidentally put a quote, or left this quote here. And hopefully that works. Cool. And then here, just go ahead and run the cell. It'll bring up an image, kind of similar to what we were doing before. We're reading in an image. This specifically is just looking at one of the test images that was downloaded in our test data set. So it's one of these goose object detection images we're loading in, but it was one the model's never seen before. I made sure it was one of the test data set. And then we're using OpenCV to read it in as the variable IM now. And then we're going to create a new variable called outputs. And we're going to feed the predictor that image, and it's going to return the bounding boxes as well as the predicted class for it. So we're going to draw those out with the visualizer that is from Detectron 2. Scale 0.5 just means we're scaling the image down to be displayed here at a smaller size. And then we're going to draw those outputs out and print out the image. So we got this. You should have gotten something like this. Did you get this? If so, you trained your first model and you ran it on an image. If you've never done computer vision, maybe it was your first model, maybe it wasn't. That's really cool. This is already really powerful and really kind of a really strong foundation for solving a lot of problems. So even just from this, let's see what we can do, right? So here's actually what an image looks like. So it's just an array in this case because it's a red, green, blue color image. Each pixel is represented by red, green, and blue. And it's just a really long array. But here, let's print out what was returned from our model. And you'll see this if you work with PyTorch a lot. You're saying, you have some sort of variable or whatever, and you're moving it to CPU. That means because you're using a GPU to run the model and get kind of predictions back. And you now want to move what got predicted back to the CPU to just kind of use in the rest of your code without the GPU. So if you see something like this to CPU or to a device, that's very common in PyTorch. It means you're doing predictions or training somewhere and you're moving stuff off the GPU now to the CPU. So we look at the output from our model, you can see it's kind of this object here. It says number of instances. So even just from that first thing, we could say, there's 2 geese. So if you're doing a wildlife counter and you just want to know how many things were in a frame, you can already do that just with what we trained here. You get some other image details. And then this is the fun stuff. You get these prediction boxes, these bounding boxes. And so these are all the coordinates, and that's what draws this out, right? It predicted this is in this box, a goose is contained. And you can also build your own visualization library. So like Detectron 2 visualizer is awesome to get started and a really easy way to draw outputs on your images. But if I'm creating something and I want to have control over the visualization, what you can do is you just create or you take all this stuff returned and create your own functions with OpenCV or Pillow, take these bounding box coordinates and you can draw your own rectangle from them. And then you get scores. So it says, it was 99% sure one of them was a goose or confident, and one it was 98% confident. And then you get the predicted classes. In this case, they're all 0. Python, like most programming languages, starts at indexing at 0. So if you had a goose, a duck, and a pigeon, the goose would be like index 0, the duck would be index 1, and the pigeon would be index 2. So in this case, we're only getting zeros because we only have one class. Here, just a tiny little piece of code, you can say detected 2 geese, right? So you could change this to detected a gander. I think I see someone commenting probably from before. I don't know if this technically makes a gander. So you could just change this. Oh, well, no, you'd actually have to do like an if statement to say, if more than 1, then say gander or something like that. So we'll do the same thing just on one more image just to see. And yeah, it works even. And there's kind of a story behind this data set, why there's geese photoshopped in my living room. And it was kind of, I did a talk around overcoming some common problems in data sets by creating your own synthetic data. So if you had trained, I'll actually talk about this later if we have time, if anyone wants to hang out or something. But I'll keep going because we're almost out of time in case anyone has to go. I link in here, these posts talk way more about the evaluation metrics, but really we're just running that average precision again, but on the test data set. So remember, we can use that validation data set, change some hyperparameters, like maybe I would change the learning rate, change how many epochs are during training to get a good score on the validation. And then once I'm like, okay, cool, let me go actually make sure that it works on data it's never seen before and that I didn't use to tune my network, then I want to run it on a test data set. So this is what this is doing, and we're feeding in my test data set instead of validation here. And we see we're getting pretty similar results to what we got on the validation. So that's good. All right, so we did it on images. Let's quickly go ahead and do this on video, and then I will catch up on questions. So here we're just importing something called YouTube video display. This is just shows a video in the Colab notebook. And I have a little video here that is just some geese walking around in a park. So we want to now run our model on this video, and hopefully it'll work well. So here we're going to say pip install YouTube download. These other things are commented out because I think at one point I had to use like a different version of something, but don't worry about these comments. I should probably just remove them. We installed YouTube download. Now we want to download that same video that I have here. So that's the URL to it. And we're saying the frame rate, we want it to be 22. And then the output is going to be video.mp4. So we're going to download it and it's going to show up in our instance as video.mp4. We'll run this. And now we don't actually really have to do this next step because the video isn't so long, but I included this because I think they might have it in their documentation too, because it's really convenient if you want to run your model on a video, but your video is like a minute long or something. Sometimes you'll want to run it just on a few seconds to make sure that it's actually working well on your video, because it can take a while to write to video. So if you're doing like a 10-minute video, instead of waiting like an hour or something for it to write it out, you can just do a 6-second clip and be like, okay, I feel like pretty good that it's gonna work well on my data set. And this is using FFmpeg, which is a library, and we're just gonna create a 6-second clip, and then we're calling it video clip.mp4. So we now have video mp4 in here, and then if this should refresh in a second, but video clip mp4 will populate in here too. From here, I'll go ahead and run this because this takes a little bit to run, so you should totally run this too. This is actually what's writing our goose video, and you should see progress. And you can go ahead and hit this next cell. Go ahead and play that one. It'll play after, so you can hit one and the next one won't execute until the first cell's done. And what this cell's doing is it's getting some parameters about our video, like the height, the width, the frame rate, and stuff like that. And then we're using something in OpenCV called video writer. We're going to write out something called out mp4. And these are some parameters. So if you wanted to change different encoding types, so this is going to be an MP4, you can look at all these different parameters and figure out what to change. We're going to use the native frame rate of whatever the video was at. And then we're instantiating video visualizer, which is similar to the image one from Detectron 2, but instead it'll just work on video. And then we have this function here, and essentially it's just saying, while there's frames left in this video, because a video is just really a collection of images, right? While there's images or frames left in this video, go ahead and take that frame, run our predictor on it, and save it as outputs, just like we did before for the image. But now we're going to create a frame. We're passing in here to I think change the color from RGB to BGR, because I was saying OpenCV. For some reason, whenever the decision was made, they have the BGR, the blue green, instead of red blue green. And we're creating a visualization variable, and then we're drawing those instances out to the frame. So we're drawing those outputs or this is actually where we're drawing the output, sorry. We're reversing the color here, actually. We are drawing the outputs, and then we reverse the color again. And then we're returning that visualization out of that loop. And then we essentially just tie them all together here. And what that gives us is this. Hopefully it worked. Hooray! Did everyone get similar results? Yeah, pretty well. I think so. The reason why it's so high too, and this is really important to think about in terms of data, is geese, as you know, the Canada goose, they all look very similar. So every instance that we trained on really helps, and probably almost every time you'd see a Canada goose. But if you have more complicated data types, like dogs look way different, right? Like you can have a small dog, a big dog, a lab, and a poodle, and a chihuahua, all look completely different. So you might need way more images than we did in this case for the goose. So if there's more variation, typically you're gonna need more data. But awesome, yeah, if you did this and you've never done computer vision before, good job. Give yourself a round of applause, because you went from like learning how to label a data set to actually training a model with it, which is awesome. And like I said at the beginning, you know, the most important thing after this workshop, if you're interested in like pursuing more computer vision and learning more, is to keep learning. So there's some resources in here, and there's the Slack in here. There's Medium. So I'm actually getting ready to post more tutorials on our Medium. So if you want more content kind of like this, but a written format, definitely follow there. You can subscribe on YouTube for more content as well, kind of video recorded ones. I have some other links here that describe the various types of object detection models I talked about. So I have kind of an explained article and then the actual paper. I find reading research papers a little bit daunting sometimes. So there's kind of just easier, like these articles explain them easier. Detectron 2, go check out their official, you know, GitHub for any other kind of documentation, as well as they have a Colab too that goes through like using some different data types and stuff. And then I really like PyImageSearch. If you've never been to them before, there is a great computer vision website, as well as Machine Learning Mastery. And then just here are some links for y'all in the chat. I think you already have the data labeling ones. Here are kind of all the links if you want to connect with me on LinkedIn, Twitter, GitHub, the Medium account. This kind of talks about the GitHub link in there kind of talks about the how I made the data set and why they're Photoshop, and then the Slack channel. So I will be in the Slack channel pretty much all the time. It's definitely the best place to reach out to me if you have any questions. And again, for anyone who joined, this is the link for the labeling tool that we used. Makes it pretty easy, especially if you're doing something like image segmentation or team collaboration. Has really great features for it. And I'm really excited for our other kind of ML assisted labeling features that are coming out soon. So keep an eye out. There's going to be some really cool stuff coming soon. And I'm really excited to make kind of labeling easier and hopefully training easier too. that is kind of the end of my content. So I will be hanging out though for a little bit and answering questions if anyone has any. Thank you. Good.
Great, thanks, Sage.
Yeah, you gotta stop recording now if you want.
Okay, sure. Well, I mean, if anybody have questions, you can. I mean, we have a few more minutes.
Yeah, and also
can ask in the Q&A, or if you want to speak to ask, raise your hand. You know, we just make it more flexible.
Oh yeah. Also, there are some questions in the Q&A that I didn't get to. So sorry, because I always pay attention to the chat. And again, feel free to connect with me though in all those places. LinkedIn or Slack is the best. Just if you have any questions. So I saw some people, I think, during that too, you know, talking about using edge devices and stuff like that, and definitely out of the scope of this workshop and takes a lot more time. But I'd love to try to help you where I can. But I can go ahead and read some of these other questions in Q&A, I think. But also feel free to ask any in the chat. Someone said, how do I feel like transfer learning works for data? Oh, are you letting people in with questions, Bill?
No, I did not. Actually, I just unmute a few people raise their hand. So, no, feel free to ask.
Oh yeah, go ahead.
Can you hear me?
Yep.
Yes, go ahead.
Thank you so much, Zach. I have one question about the labeling parts or annotation parts. So if you have an image that's that contains several objects, and some of them appear on the edge, or some of them are overlap one on each other, so you only see part of the object, how would you label that object? You ignore them, or you only label the part you see?
You'll want to label them if you can. So there might be some edge cases and stuff. And I think as you go and you train more models, you'll kind of learn maybe what works and what doesn't. But usually if they're overlapping, you want to label them. So let's say, I don't think I have a good example uploaded here, but let's say this goose was a little bit behind the other goose, like halfway behind it. I'd still want to label it, and it would be the square around all the parts I would see here. You know, I wouldn't be like a square here and then a square here. I would just draw another square around it. Even though they're overlapping, the model's going to look at kind of all these features of it and kind of put it together that it's another goose there. And then there were some examples in the actual data set, not the few I uploaded, but like there would be just a goose head or something coming over here, but a large part of it's off screen. But I would still want to label it because it might contain really important features to the model. And again, remember, like if you don't label every instance, you would label these as geese. But if a goose head is sticking out here and it says, oh, that's not a goose as it's learning, then it would probably start ignoring that part of the goose in the model, or it could potentially.
All right, thank you so much.
Yeah, and it can be hard if you have like a lot, like if it was like a ton of geese and there was like so much overlap, it can be pretty kind of hard to label those types of things. But I try to contain all the portion that I can see, and that'll probably work pretty well. But you can also experiment. Sometimes it might not on whatever your data set is.
Thank you so much. That's very helpful.
Yeah, it's always I feel like it's actually the hardest part sometimes.
Right.